In this video, we're going to take a look at inscribed angles and quadrilaterals in circles. So first, let's take a look at the definition of an inscribed angle. An inscribed angle is an angle with its vertex on the circle formed by two intersecting chords. The measure of the angle is half the measure of the intercepted arc. So in this figure, there's a nice picture. Let's add a little more detail to it. So our inscribed angle, we could call angle ABC. So what this is saying is angle ABC is equal to half of the intercepted arc. And the intercepted arc would be called arc AC. So in other words, that angle that sits on the side of the circle is equal to half of the arc that it creates as it passes through the circle on the other side. So let's look at the definition of circumscribed angle. It's an angle formed by two tangents to a circle from the same point outside the circle. The measure of the angle is half the difference of the intercepted arcs. And we're going to look at this in a later video and a later set of notes in practice. But this just shows you the difference between what an inscribed angle is and a circumscribed angle. But like I said, we're going to take a look at those in more detail in a later lesson, but I do want you to go ahead and draw that and write down the definition for these notes. All right, an arc intercepting a diameter is if an inscribed angle intercepts a diameter, then it is a semicircle of 180 degrees. So for example, if we have an inscribed angle, let's call it angle UP in. So if I had angle UPN in this picture, then what we talked about in inscribed angles in that first definition is that angle P would automatically have to be a 90-degree angle because it's opening up to an arc UN that's equal to a half of a circle or 180 degrees. So angle UPN would equal half of that intercepted arc or half of the 180 degrees. And so it would equal 90 degrees. All right. And vice versa, if we know that that inscribed angle intercepts the diameter, then we would automatically know that it's 90 degrees, and we would know that that arc is 180 degrees based off the fact that it's a semicircle. Okay, overlapping arcs state that if two inscribed angles intercept the same arc, then the angles are congruent. So let's look at this one. If we have angle ADB, trying to shade it, but it's already kind of colored in kind of dark. So angle ADB is this angle right here. Notice that opens up to arc AB. But angle ACB, so angle ACB also opens up to that same arc AB. So it makes those two angles congruent, and they're still equal to half of the intercepted arc. So we could say a few things about this picture. We could say that angle ADB would be congruent to angle ACB. So they are congruent, and then they are both equal to half of that arc. So both angles equal half of the intercepted arc, which is half of the 124, which would just be 62 degrees. All right. So let's move on to some examples. So in number 1, it says, find each angle and arc measure. So we want to find the angle WXY. So angle WXY is an inscribed angle in this circle. That means it would equal half of the arc that it intercepts. So it would be half of 62 degrees, which is just 31 degrees. All right, for number 2, we need to find the measure of arc DGF. So arc DGF, we want to go in that order around the circle, is equal to twice the measure of the intercept the inscribed angle. So the intercepted arc, DGF, is twice the size of the inscribed angle. So we needed to say 2 times 113 degrees to figure out the arc. So that would just be 226 degrees. We were working backwards. All right, number 3, we want to find the measure of angle RST. Angle RST is right there. And the measure of angle RUT is right there. Notice both of those angles are intercepting the same arc, which is arc RT. So we know those angles are equal to one another. We just have to figure out the measure of that arc. And then we're going to need to divide it by 2 to get the measure of those angles. All right, so we need to say that we know that all the angles and all of the arcs of a circle will add up to 360 degrees. And we're only missing arc RT in this picture. So we could say 360, and we could subtract all of the rest of them, or we could add them up and then subtract. It doesn't matter which way you go about it. Let me get a little bit smaller pin width so that fits better. So let's say 360, and then we're going to subtract 75, 139, and 64. And then what we have left over is 82 degrees. And so arc RT is now equal to 82 degrees. But then those 2 inscribed angles are going to be half the measure of that intercepted arc. And so 82 divided by 2 would just equal 41 degrees. Let me make that look a little better. All right, so they're both just 41 degrees. But first we had to figure out the measure of that arc that they both are intercepting. Okay, number 4 says find X. We're given angle CDE. So let's label that. Angle CDE is given, and that's 8x minus 9. And then that angle, the inscribed angle, is intercepting arc CE, which is the 158. So we know that the angle is half the measure of the intercepted arc. So if we take 158 and we just divide that by 2, we get 79 degrees would be the measure of that inscribed angle. And then we could figure out what X is. So let's say 8x minus 9 is equal to 79. Ooh, and then let's add 9 to both sides. So we get 8x is equal to 88, and then just divide both sides by 8. So we get x equals 11. Always check and make sure that's all you needed, and that is all we needed for number 4. Number 5 says find X, and we're given this circle, and we know we have angle XWY is equal to 7x plus 6. And then we're given the angle X is equal to 114. So we know if this angle is 114, that is half the measure of this intercepted arc, which is going to help us solve the problem. So we need to say 114 times 2. So 114 times 2 would be 228 degrees. And then we have 78 degrees is arc XW. And that way we could figure out the missing piece over here. So say 360 minus 228 minus 78 would leave us, let's write all that down. So 360 minus 228 minus 78 would leave us with 54 degrees for the measure of arc XY. And then we can finally put that together with this inscribed angle. Remember, the arc is twice the size of the angle, or the angle is half the measure of the arc. And so we need to set 7x plus 6 is equal to half of 54. So 54 divided by 2 would just be 27. And then we can finally figure out what x is. So let's subtract 6. We get 7x equals 21 and divide by 7. So we get x equals 3. Always check and make sure that's what you're looking for which it is. So we're done with number 5. Let's look at number 6. 6 says the measure of angle ABD. Let me draw that. Angle ABD is 6x plus 26. And the measure of angle ACD, so ACD is 13x minus 9. And we want to find the measure of arc AD. So what we do know is that both of those angles, those inscribed angles, overlap and they intercept the same arc, AD. And so we know those two angles would be equal to each other, which is going to help us solve the problem. So let's say 6x plus 26 is equal to 13x minus 9 to start solving for x. So if we subtract 6x, we get 26 equals 7x minus 9. Then let's add 9. So we get 35 equals 7x. And divide by 7. So we get x equals 5. But we don't want just x this time. We want to find the measure of arc AD. So first let's plug it back in to figure out the measure of those angles. And then we can double it to figure out the intercepted arc. So if we say 6 times 5 plus 26, that's like 30 plus 26, or it is 30 plus 26, and that would just give us 56 degrees for each of these angles. And then the inscribed angles are half of the measure of the intercepted arc. So we need to say 2 times 56 would be 112 degrees for that arc AD. All right. For number 7, it says the measure of angle KJL. So let's say K to J to L. So we know we're talking about that angle is 3x plus 2. The measure of KLJ is 7x minus 32. So K to L to J. So you know which angle it's referring to. You can draw that out. And that would be 7x minus 32 for that angle. And then if you notice something really important is this angle K is inscribed in the circle but opens up to a semicircle. And so we know if it opens up to this semicircle arc, it's half the measure of that, which makes it a 90-degree angle, and that's going to help us solve the problem. So eventually we're going to figure out the measure of arc KL. But in order to do that, we got to figure out the measure of angle J, and then we got to multiply it by 2. So let's work on that. We can say that we know that the angles of a triangle always add up to 180. So let's say 3x plus 2 is angle J. 7x minus 32 is angle L. And angle K equals 90. And they all add up to 180. And that's going to help us figure it out. And so from there, we just need to say, let's combine like terms. So we have 10x minus 30 plus 90. So let's go ahead and put that together. So that would be 10x plus 60 equals 180 and subtract 60. So 10x equals 120. We can divide both sides by 10. So we get x is equal to 12. And so then you can say angle J, let's come back over here and plug it in now. So angle J is 3 times 10 plus 2, which is 32 degrees. And then the arc that we're looking for, so arc KL, is twice that. So 2 times 32 would mean arc KL is 64 degrees. All right, so we need to look at a few more examples with one last property. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Remember, supplementary means they add up to 180. So let's just write that angle A plus angle C in that picture over there. They add up to 180, and angle excuse me, let me get my eraser. Angle B plus angle D, they would also add up to 180 degrees. So using this last property of inscribed angles, we're going to look at a few more examples. So for number 1, it wants us to find the measure of angle J. So looking at the figure, J is opposite of L, and so these two should add up to 180. So let's just say 180 minus 92 to figure out angle J, which is just going to be 88 degrees. So that's pretty quick and easy if that's all we need. And then angle M is 45, and angle M and K are opposite angles. So angle K would have to be 180 minus the 45, which would just be 135 degrees. So those are just pretty direct opposite angles add up to 180. That's all we needed for that one. For number 2, let's see about this one. Angle Q is opposite of angle S. And so angle S we know would be 180 minus 93, which would just be 87 degrees. We just have to subtract. And so if we know that that is 87 degrees now, that might help us out. Let's see. Angle R. So angle R opens up, it's inscribed, and it intercepts this very large arc. Arc QPS. And we know the measures of those two arcs combined. So 126 plus 90, and then we'd have to divide by 2. So 126 plus 90 is the arc. And then if you divide that by 2, you get the measure of angle R, which is 108. Whoops, 108. And then we could definitely just figure out P from there, because P and R are opposite angles. And so P would be 180 minus 108, which would just leave us with 72 degrees for angle P. Okay, I think we have one more last example. So for number 3, it wants us to figure out X and the measure of angle J. So let's start with angle H, because H is going to help us to figure out the rest. We know that H is an inscribed angle, and it intercepts the arc GJI, this big arc out here, which we know the measure of because it was given to us. So we have 50 plus 96. So this total arc measure from G to J to I. So that total would be 146 degrees, because that's 96 plus 50. Angle H would be half of that. So we know angle H would just be 73 degrees, because that's 146 divided by 2 gives us 73. Now that's going to help us out to figure out what X is, and then we also need to figure out the measure of angle J, but now we can get there. So these are opposite angles. So remember, in a quadrilateral that's inscribed, opposite angles are supplementary. So we know that angle J will equal 180 minus 73, which will be 107. And then we can say 12x minus 25 equals 107. So we know angle J is 107. That's one of our answers. We just got to figure out what X is. So this last step, and we'll get there. So let's add 25 to both sides. So we get 12x is equal to 132. And then just divide both sides by 12. So we get x equals 11. And then we already found the measure of angle J, which was 107 degrees. All right, so that's the last example for this video. Thanks for watching.